Hi friends, this is Rounak sir from Vidyaam Academy Pune. The topic we are working on is differentiation, and the concept today is an extension for inverse function. So we have already seen how to find differentiation, how to find derivative of inverse function. This is just an extension. You can say a next part where we'll be solving sums on differentiation. On a screen you can just have a look at some kind of formulas that we have already seen. We'll just have one simple revision of this. You can just have a look at the formulas. Sine inverse of sine theta comes out to be theta, cos inverse of cos theta is theta, tan inverse of tan theta is theta. We have already solved numericals on this. Now we have basic compound angle formulas, trigonometric formulas, sine of a plus b, sine of a minus b, that is sine a cos b, cos a sine b format. Similarly for cos, there is cos and sine term. With that, sine 2 theta, all the double angles, sine 2 theta, cos 2 theta, and we have tan 2 theta. If you look at the formulas, you get sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta. Cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. And tan 2 theta comes out to be 2 tan theta upon 1 minus tan square theta. So, as and when required, we'll be using all those formulas. I have just written it on a paper so that it is bit easier for us. So we'll be solving few sums, so I'll be going for the sums immediately. Let's have a first sum for us. Let's practice this out. So we have a first sum given, that is y equal to, what they have written is, they have written something like sine inverse of, along with this there is a term called as 4 sine x plus 5 cos x upon under root of 41. So you just have to observe the question. What we need to do for such kind of question is, the term, the question starts off with what? Sine inverse. The major portion is sine inverse. If you focus on this, if you have sine inverse in your question, try to get sine term in your bracket so that sine inverse and sine, they got cut and we get answer has to be only theta. So the simplest combination we'll be trying is sine inverse function will have sine term inside. So let's separate this out first. So I'll be writing this as again. So we get sine inverse of 4 upon root 41 along with sine theta, sine x, 5 upon root 41 along with cos x. So we have got our terms. Now what we need to do is, the simplest combination that we can do is, there is something into sine x, something into cos x. So something into sine x is already there. What we can do is, we just need to go for some kind of adjustment, and the adjustment clearly tells us what we can do is, we can just put 4 by root 41 term as to be cos of a. So this clearly gives us, if cos a is assumed to be 4 by root 41, we can go for clearly sine square of a is equal to, that is trigonometric identity, 1 minus cos square a. So putting that 1 minus cos square gives you 16 upon 41. So if you simplify, you get sine square of a is equal to 41 minus 16, that is 25 by 41, and ultimately the answer for sine that you get is 5 by root 41. So I'm just putting a box for sine a equal to 5 by root 41 and the assumed thing, that is cos a equal to 4 upon root 41. What you have to do is, you just have to put those values in your y, So if I put those values in y, what do I get? Y equal to, I get sine inverse of, the first term that I am here with is 4 upon root 41. That I know we have to substitute this as to be cos a sine x plus 5 by root 41 is sine a cos x. To be specific, sine inverse of, I'll write it in the proper format. The format is sin x cos a plus cos x sin a. So this formula, if you compare it with the formula of compound angle sine of a plus b, I get my answer as to be sine inverse of sine of, I get my answer as to be x plus a, and that would be clearly equal to y. So as we all know that sine inverse and sine term, for such term we get our answer as to be direct theta. In this case we'll be getting our answer as to be x plus a. So now if we differentiate it with respect to x, we get dy by dx is equal to derivative of x is 1 and derivative a is equal to 0. So our final answer in this case comes out to be 1. I hope you have got the sum. The only thing in this sum is if you get sine inverse, try getting sine term inside. If you get cos inverse, try getting cos term inside, and so on. You have to just deal with such sum. So if I go with the next sum now, so you'll be helping me out for next sum also. So let's move on for the next particular sum. So next sum clearly tells us, just a second, I'll just arrange the next sum tells us y equal to cos inverse of, the term has been 3 cos 3x. You will be helping me out now, 4 sin 3x upon what do we have is the term which is 5. So you'll be helping me out in this. So what you have got, looking into the sum starts off with cos inverse. So we'll be trying to get cos inside. In order to take cos term inside, just need to separate the terms first. We get cos inverse of 3 by 5 cos 3x minus 4 by 5 sin 3x. Alright, so what you have to do is just have to go by the formula, and the formula tells me that I just need to put cos a term as to be 3 by 5 where is any constant angle. So cos a is equal to, if I get cos a is equal to 3 by 5, so according to trigonometric identity I should get sin square a is equal to 1 minus cos square a. Alright, that is equal to 1 minus 9 by 25, that is equal to 16 by 25. So if this is the case, then I get sin a as to be 4 by 5. So I'll have a boxes for terms like sin a as well as cos a. Putting this in the formula of y, I get cos inverse of, you can just have a look at it, 3 by 5 can be written as cos a cos 3x minus sin a sin 3x. Now I think so you have got the answer. Cos inverse term will remain as it is. We know cos a cos b minus sin a sin b. So cos a cos b minus sin a sin b results in cos of a plus what? 3x. Perfect. So again cos inverse and cos terms get cancelled, as in cos inverse of cos theta is only theta. We get y is equal to only a plus what? 3x. Now if I differentiate it, I get dy by dx is equal to 0 plus 3 into x. For x the derivative is 1, so your answer in this case comes out to be only 3. I hope you have got the idea as to how to deal with this particular sum. Now the similar way we'll have one more sum and we'll see how it goes. Let's have a sum. I'll write it here. The sum is cosec inverse of 10 upon, there is 6 sin raised to 2x, along with this minus 8 and cos raised to 2x. So the sum looks very promising over here. The important pattern in this case is, if I consider this to be as y, your job is what? You just have to try getting sin inverse, cos inverse and tan inverse of tan inverse in the question. So what we have right now is what? Cosec inverse. We know the relationship, and I think so you must also know that you can simply write cosec inverse of x, right, as to be sin inverse of what? 1 by x. I repeat, you can simply write cosec inverse of x as to be sin inverse of 1 by x. So the same policy I'll be repeating over here, and the term that I get now is a bit different, that is sin inverse of, you just have to take reciprocal of this, comes out to be 6 sin 2 raised to x minus 8 cos, again 2 raised to x, and everything gets divided by what? 10. Now if I simplify this, I get sin inverse of, just have a look at it, this is 6 by 10 can be written as 3 by 5 along with sin 2 raised to x minus 8 by 10 can be written as 4 by 5, and there is cos of 2 raised to x ka term. So this is all I have got for y. Now you must have got, if I get sine inverse in the question, my basic aim is to get sine in the bracket. In order to get this in the bracket, what I will do is, we all know that now the next step would be I need to adjust for 3 by 5 term as well as 4 by 5 term. So how will I adjust this? I will simply do one thing. I will just put 3 by 5 to be as cos A, which leads to sine inverse of A to be equal to 1 minus cos inverse of A, like we have been solving this. 1 upon 9 by 25. If you simplify, this comes out to be 16 by 25. Now if you get this as to be 16 by 25, the answer for sine A you get is 4 by 5. So I have just again boxed it. So I have got cos A as well as sine A as to be our substitutions. Let's put it in y. So we must have got y as to be, you can just have a look, sine inverse was as it is. The term over here is 3 by 5 can be simply written. You can just have a look at the term. The term over here was 3 by 5 is simply replaced by cos A. So this becomes cos A sine 2 raised to x, alright, minus sine A cos of 2 raised to x. This is what we are getting right now. So if you look at all these things, if you simplify this, what do you get is y equal to sine inverse of, you can simply write this as to be sine A cos B minus cos A sine B. So sine A cos B clearly gives the sine of 2 raised to x minus, you can write this as to be A, because the format clearly tells us sine A cos B plus minus cos A sine B. So if I simplify this, I get y to be equal to 2 raised to x minus A, and if I find derivative, if I go for derivative of this, I get dy by dx is equal to derivative for 2 raised to x, we all know that 2 raised to x into log 2, and for A the derivative is clearly equal to 0. So the final answer that we have been getting over here is 2 raised to x log 2. Thank you.